Dear all, today I am going to explain Software Lab 2 assignment number 8, IPC using pipes. First, we'll go through the problem statement. Inter-process communication in the Linux using following: FIFO, first in, first out, full duplex communication between two independent processes. First process accepts the sentence and writes on one pipe to be read by second process. Second process counts the number of characters, number of words, number of lines in an accepted sentence and writes this output in the text file. And writes the contents of the file on the second pipe to be read by the first process and display on the standard output. Now first we'll go through the FIFO, first in, first out. We used one pipe for one-way communication, two pipes for bidirectional communication. Does the same condition apply for the name pipes, that is FIFO? The answer is no. We can use a single name pipe that can be used for the two-way communication. That is the communication between the server and the client, plus the client and the server at the same time, as the name pipe support the bidirectional communication. Now the capacity of the FIFO. A FIFO can have a multiple readers or the multiple writers. Bytes from each writer are written automatically up to the maximum size of the pipe buffer. So the maximum capacity is 4 kilobyte on the Linux. A system call mknode is used to create the name pipe, which is a kind of a spatial file. The syntax is int mknode parameter, path name, mode, and the device. This system call will create a spatial file, the file system mode, such as ordinary file, device file, or FIFO. The argument to the system call are path name, mode, and the device. The path name along with the attributes of a mode and device information. The path name is relative. If the directory is not specified, it will be created in the current directory. The mode specified is the mode of the file, which specifies the file type, such as the type of the file and the file mode as mentioned in the following. The device field is to specify the device information, such as a major or minor device number. So this is mknode. Now we'll go through the client-server paradigm first. The client-server paradigm comprises a single server process which works all the time. It receives a request from the client, gives the responses. A client is a process that manages the inputs and outputs for a live user. The clients come and go, but the server works all the time. The clients communicate with the server using the IPC mechanism. Each process in a paradigm has a system-wide mechanism for receiving the messages. In this, use the FIFO as the mechanism for receiving the messages. That is, the server will have a FIFO where clients can put the message for the server. Similarly, each client will have a FIFO where the server can put the message for the client. So this is overall client-server paradigm. Now, how to create a FIFO file? In order to create a FIFO file, a function called mkFIFO is used, int mkFIFO. mkFIFO system call makes a FIFO spatial file with the name, path name, and here the mode specifies the FIFO permission. It is modified by the process in the usual way. The permission of the created file are read, write, and execute permission. Now here's the go through the program code. Two pipes have to create it, pipe 1, pipe 2, buffer, then mkFIFO. Now server is responsible to read the data entered by the client in the file info.txt and calculate the number of words, lines, and the characters, that is the result. And that result again back sent to the client with the file info.txt into the opinion. We'll go through the code of the client. Now client is responsible to enter the data. The data is read by the server in info.txt file, calculate the result and result back to the client. So this is the overall the program is work. Now how the client program is executed, you have to compile the program with the client.c and execute the program with the ./it. Your client is responsible to enter the statement, such as I have to enter the statement RSUITT, and this statement is received at the server side. Server calculate the result and back the result in the form of the number of words, lines, and the characters. Now we'll see live how to execute this program onto the online CoCalc terminal. So now I share the screen. Now here, online CoCalc terminal is used for executing this IPC FIFO program. At the client side, you write the program, and server side, you write the program. Okay. Now we'll see here. First, you start the server with the compile the program gcc server.c and execute the program ./a.out. At the client side, you please enter your statement. You enter the statement here at the client side RSUITT, which is ended with the dot, then only the server it can capture this string. Once I enter the statement, server it can catch the string, calculate the number of word, lines, and characters, and store this result in the info.txt file. Client, it will go to the info.txt file and it will be read the result, which is seen by the server. So this is the overall execution of your client server by using the FIFO. Thank you, all of you. Thank you for watching this.